Hello, in this video, I will go over the family square root graph. I will go over how to graph a square root graph and with its translation, reflection, and stretch. So we're definitely gonna go over the square root graph. So this is the parent graph. As you can see, it starts at 0 and it slowly starts to increase. So what the domain of the square root graph just for the parent graph, it is from bracket 0 to infinity. And then the range of the square root graph is bracket from infinity. And they do include it. So it would be wrong if you say the domain would be from 0 to infinity. If you use a parentheses, they include it. The same thing with range. I do not know why, the reason why they use a bracket, but that's just how it is for square root graphs. Okay. Okay, so now you know what it looked like. Maybe we can start graphing. So graphing a square root graph with translation, reflection, and stretch. So for example, y equals 2 square root of x plus 2 plus 5 has a lot going on. It is from the parent family y equals square root of x. So it looks like there's one, two, three. There's three things that's going on in this graph from the parent family. This graph has, three things that's going on. It has a horizontal shift. So this x plus 2 means you have a horizontal shift of not 2 units to the right, but it's actually 2 units to the left. If you recall, horizontal shift is always the opposite for some reason. So if there's a -2, it's really +2 to the right. And if it's +2, you're really shifting it 2 units to the left. Okay. The +5 is your vertical shift, and it is what it is. You do not change it. Vertical shift is either going up or down. Since this is a +5, we are going 5 units up. Okay. And then what about this 2? This 2 is a vertical stretch. Okay. I'll go over shifts, stretch, and reflection on next slide. It all makes sense. Right, so now let's review shifting, reflection, and stretching of a square root graph. So you have a vertical shift c units upwards of h of x equals, I don't know if you can see the red, but it should be a square root of x plus c. I don't know why it does that, but yeah, this should be square root, if you can see it. If the constant is outside the square root, that's how you know you have a vertical shift. And it is what it is. If it's positive, you're going up. If it's minus, it's going down. So that's rule that comes with the next rule. H of x equals square root of x minus c. It's outside the square root and it's a minus, so you're shifting it some units down. Statement 3. Now, if the constant is inside the square root, you have what's called a horizontal shift. And with horizontal shift, it's always the opposite sign. Since this is a minus, you're actually shifting its units to the right. I don't know why the reason, but that's the way it is. And then rule 4 is also a square root graph. It's a x plus c, so you're shifting it units. You're doing a horizontal shift some units to the left. Okay. Statement 5. You a reflection across the x-axis. So if there's a minus outside the square root, that's how you know you have a reflection across the x-axis. If you have a minus inside the y-axis, inside the square root, you have a reflection across the y-axis. Okay, and then let's talk about vertical stretch. So if you have a number outside the square root, like for example, y equals 5 square root of x, that is called a vertical stretch. And if the constant's still outside and the constant is less than 1 but greater than 0, so for example, like a fraction, 1/2 square root of x, that is considered a vertical shrink. Okay. And then 9 is a horizontal shrink where C is greater than 1. So if the number is inside the square root, so for example, if it was y equals the square root of 5x, now you can't just take out the 5 and put it outside the radical. If it's inside the radical, then it is a horizontal shrink. And if it's still inside the number, but still less than 1 but greater than 0, so like, I don't know, 1/2, yeah, you're gonna have to, it is a horizontal stretch. Okay. Let's start. Now you have that piece of information. Two more rules I have to go over. Oh wait, I went over the rules. Never mind. So let's start graphing. So how do you graph? Let me erase this. So how do you graph a square root graph with horizontal, vertical shift, and stretch and reflection? So for example, y equals -2 square root of x minus 2 plus 5. It looks like there's lots going on. What does the x minus 2 represent? It is a horizontal shift of 2 units to the right. What does this plus 5 mean? It means a vertical shift of 5 units up, not down. And then this -2. So there's actually two things going on. This minus means reflected across the x-axis. And then this 2 means it is a horizontal, what is that? It's outside the square root, so we know it's a vertical stretch. Okay, so how would you graph this? Do not make a table. That I mean, you can if you really want to, but it's hard because the domain is no longer all real numbers, so you can't just use any x values you would like. There are restrictions, so I wouldn't recommend making a table. What I would do is like what I did right now, write down everything you know about this graph. Okay, that's very helpful. And then what I would do is pick 3 coordinates from the parent graph. So what I mean by parent graph, y equals square root of x, right? From this equation, you're going to pick 3 points, right? So this would be, if you use 0, it'd be 0. If you use 1, the y value would be 1. And if you use -1, you can't use -1 because your domain is from 0 to infinity. Like you could do 4 and then your output would be 2, right? So pick 3 points from this graph, and then you would just do the add-ons one at a time. And I will explain it. It's actually easier than it looks. So yeah, and then do not try to do it all at once, because if you do it all at once, you can easily make a mistake. Okay, so let's start graphing. So let's start with graph 1. We have y equals square root of x minus 1 plus 4. So what I would do first is start with the parent graph. Let's call the parent graph h of x square root of x. So that's our parent graph, and we need to pick 3 points from this graph. So for example, if you plug in 0, your output is 0. If you plug in 1, your output is going to be +1. And then if you plug in 4, your output would be 2. So if you want, you're going to graph that. Keep in mind this graph is not a scale. 2, 3, 4. So 1. So if we're going by increments of 1, this one's actually 1, 2, 3. This is 4. So we're going increments by 1. So this is 5, 6, 7, 8. 10, 11, 12. Okay, this is 1, 2, 3, 4. You get the idea, right? So we're going by increments of 1. So if we graph that, 0, 0 would be right here. 1, 1 would be right there. And 4, 2 would be right there. Okay, graph the line. It would look something like this. We'll call it h of x equals square root of x. Okay. Now we're going to do, let's use red. Let's call this, I don't know, g of x. And then the next graph we're going to use is the one with the horizontal shift. So x minus 1. Why did I put x minus 4? It should be x minus 1. So what does that mean? You're shifting it 1 unit to the right, or you're adding 1 to the x value. So what that means is you're adding 1 to the x value. So from 0, 0 is no longer going to be 0, 0. It's going to be 1, 0, right? You're just adding x. You're adding 1 to the x coordinate, right? And what do you think 1, 1 would be? It would be 2, 1. And what do you think 4, 2 would be? It would be 5, 2. Okay. Go ahead and plot it. 1, 0 is right here. 2, 0 is, 2, 1 is 1, 2, 1 right here. And then 5, 2 is 1, 2, 3, 4, 5, 1, 2. Okay, connect the dots. Okay, so it would look something like that. So this, yeah, this is going to be g of x equal to square root of x minus 1. And then the next one, let's use pink. Let's call it r of x. Or no, let's call it our final one, y equals. Okay, so what does this plus 4 mean? It's a vertical shift of 4 units up. So what that means is you're adding 4 to the y coordinate. Okay, so 1, 0 would be 1, 4. 2, 1 would be 2, 5, right? 4 plus 1 is 5. 5, 2 would be 4 plus 2. So you're only adding 4 to the y. So that would be 6. Okay, go ahead and plot it. So 1, 4 is 1, 2, 3, 4. 2, 5 is 5, 6 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so it would look something like this. Okay, so this is your final graph. Now you don't have to draw these other two graphs like individually, but you do have to do these steps. So if you can, once you do these steps, you can just graph these ones, and that would be your final graph. So I was just showing you what each step would look like. Okay. So that's how I would do it. I wouldn't make a table. Yeah, let's move on to example 2. Okay, oh, shoot. Whoops. It said to do the interval notation. That's one thing I forgot to do. So let's briefly talk about the domain and range. So it's the pink one, our final graph is. So what would be my domain in interval notation? It looks like our smallest x value is from 1. So it's going to be bracket 1 to infinity. And what do you think the range is going to be? let's see, our smallest y value of this graph is 4, right? So we include it, so it'd be bracket 4 to infinity, parentheses. Okay, so that's how you find, that would be the domain and range in what's called interval notation. Okay, let's move on to example 2. Okay, so graph and determine the domain range. Oh, this does not have a graph. It's okay. I'll just draw the graph individually. So let's start with the parent graph. Y equals, let's call it not y, let's call it h of x, square root of x. So we start with the parent family always, and then from the parent family, you pick 3 points. So if you use 0, 0, it'd be 0. If you plug in 1, 1, if you plug in 1, you get an output of 1. And if you plug in 4, you get an output of 2. You can you don't have to use 4, you could use 5 or 6, but the reason why is just I don't want to deal with decimals. Okay. So now what I'm going to do is graph one of the add-ons. So which one do you want to do? Which add-ons do you want to start on? Let's start with the horizontal shift. So let's call this, I don't know, let's call it r of x. And then it's going to be square root of x plus 1, right? So what that means, x plus 1 is a horizontal shift, and we're shifting it 1 unit to the left. Okay, so yeah, what you're going to do is on the x value, you're going to subtract 1. So 0, 0 will not be 0, 0 anymore. It would be negative 1, comma 0, right? 1, comma 1 would not be 1, comma 1. It would be you subtract 1 from the x, so that would be 0, comma 1. 4, comma 2, you would subtract 1, so that would be 3, comma 2. Okay, now let's move on to we'll call it, what should we call it? G of x. And which add-on would you like to do? Let's do this negative 1/2. So it's a shrink. I think it is the C value. There's two things that's going on. It's a reflection across the x-axis, and it is I would call it a vertical shrink, right? But what you really have to do, okay, so you have negative 1/2 square root of x plus 1. Okay, so we're just adding the negative 1/2. What you would just have to do is you would just have to multiply the y coordinate. So if you have anything outside the square root, you just have to multiply that by that number, right? So negative 1, comma 0 would be negative 1, comma 0, because all you have to do is multiply the y coordinate by negative 1/2. So what's 0 times negative 1/2? 0. Okay, what about 0, comma 1? That would be 0, comma what? So you multiply 1 by negative 1/2, so that is negative 1/2. And then 3, comma 2 would be 3, comma, so what's 2 times negative 1/2? Negative 1, right? 2 times negative 1/2 is negative 1. Okay, good. Now let's do the final one. Let's use, what color should we use? How about we use blue? How about brownish? And let's call it the final one, y equals negative 1/2 square root of x plus 1 minus 2. So the add-on is a negative 2. And what you have to do is So if you have a constant outside the radical, that's a vertical shift, and it is going to be vertical shift of 2 units down. So what you would do is subtract 2 from the y coordinate, from this coordinate. So you always start from the previous. So -1 comma 0 is going to be -1 comma, so you subtract -2. So 0 minus 2 is -2. 0 comma -1/2. What do you think that's going to be? You might have to use a calculator. So it's -1/2 minus 2. It's okay to use a decimal. So what is negative? That's -2.5. Okay. What about 3 comma -1/2, -1? That would be 3 comma, you subtract 2. So that would be -1 minus 2 is -3. Right? And so what you're going to do is just plot these 3 points and you have your graph. Yeah, I don't know why this doesn't have a graph. I'll just make one. We're going increments of 1. -1 comma -2 is right here. 0 comma -2.5 is right about here. And 3 comma -3 is 1, 2, 3, 1, 2, 3. Okay, so it's going to look something like this. Now, the good news is there's no, what is it called? No asymptotes, so we don't have to worry about this. So, yeah. So based on this graph, could you name the domain and range? So the domain, the smallest x value looks like it's at -1, right? So it's going to be bracket -1 and then to infinity parentheses, correct? And what do you think the range is going to be? So my smallest y value looks like it's at smallest y value is going to be at uh, or what's our largest? Because this graph is a little bit so we're smallest y value, or so this graph, because it keeps on going down like this, our smallest y value is -infinity. So what's our largest or our most positive y value? It looks like it's at -2, right? So that's our largest. So our largest, so we're going to go from -2 bracket, and then it just goes to, no, we go from smallest y value to largest. So our smallest y value is actually from -infinity, right? So at parentheses, because infinities always have that parentheses, and then it gets very close, it stops at -2.5, because that's the most positive. Then the most positive is -2, not -2.5. So it's -2 and then bracket. Okay. Yeah, we'll stop here. We'll do the other examples in another video.